So now we're going to move on to an actual problem, word problem. So we have here an exponential function for concentration as a function of time. And what it's asking us here in part A is what are the units of 3 and 2 here in this equation. So what we know here is that C, the concentration, is in units of moles per liter. So we automatically know that 3 is in units of moles per liter as well. And we know that time is in minutes. So since time is up here and its units are minutes, then we know that -2 has units of inverse minutes. Or, so I would probably write it. Okay, and now it wants us to do a linear interpolation. So we're gonna suppose that at time equals 0 and 1, we take measurements of the concentration. And we're going to interpolate to estimate the concentration at a time in between 0 and 1, so that time is 0.6 minutes. And then we're also going to try and estimate at what time the concentration is going to reach this low value of 0.1 moles per liter. And then we're going to compare these results to the true values of these quantities, and the true values of these quantities would literally just be from this equation. You'd plug in T equals 0.6 to this equation, get the true concentration, or you plug in 0.1 up here and get the true time at which that concentration will exist. But first, we are going to do the interpolation. So all the way back on page 1, I gave y'all a sheet of formulas, and I'm going to pull the interpolation formula from there, and that is going to be y equals y1 plus x minus x1, x2 minus x1 times y2 minus y1. And then we are going to figure out what the values are for the concentration at time equals 0 and time equals 1 minute. So at t equals 0 minutes, the concentration is equal to 3 exponential -2 0. And since we know this is 0, this is just going to be 3 moles per liter. And at time equals 1 minute, we are going to have C equals 3 exponential -2 1, which is equal to 0.406 moles per liter. And then what we're going to do is we're going to use these 2 points, so 0, 3, and 1.406, to develop a linear equation so that we can interpolate these values. And so our equation is going to go something like this. So we're going to have C, which is our y, is equal to C1 plus T minus T1 over T2 minus T1 times C2 minus C1. And we're going to plug in these 2 points that we have into this equation and simplify that down. So we're going to plug in, we don't have C, that's just our Y. So we have C1 is equal to 3 plus T minus 0, which is T1, and then T2 is 1 minus 0, 0.406 minus 3, which is equal to 3 plus T 0.406 minus 3, and simplify this down to be C equals minus 3, 0.406. So C is equal to negative 2.594 T plus 3. And this is our equation that we are going to be using to estimate these values up here. So now, once we've used these 2 points to develop this linear equation, we are going to solve for the estimated values using our linear equation. So we have here, we're gonna have our estimated over here, which is what we get using this linear equation that we developed from the 2 points. And then we're gonna have our true values over here. So our estimated values for, so we have C at T equals 0.6 minutes is what we want. So that is going to equal negative 2.594, 0.6 plus 3. So C is equal to 1.4 moles per liter at T equals 0.6 minutes. And then the next estimated value that we want is our time when concentration is 0.1 moles per liter. So time when concentration equals 0.1 moles per liter. And what we're gonna do here is plug in 0.1 equals negative 2.594 T plus 3. So 0.1 minus 3 divided by negative 2.594. And we get T is equal to 1.12 minutes. So that is a point that is past the 2 points we are at. So we are extrapolating here. We are getting a value outside of the range of where this line was developed in, because we developed this line between the points T equals 0 and T equals 1 minute. And we're estimating outside of that range here, getting 1.12 minutes. And then our true values are going to be what we get from just plugging in to this equation here. So we are gonna just plug in these. So here we have C when T equals 0.6 minutes. And that is going to be C equals 3, exponential -2, 0.6. So C equals C equals 0.9 moles per liter. And then here we are going to do time when C is equal to 0.1 moles per liter. And we are going to get, so we're gonna have 0.1 here equal to 3 exponential -2 t. So we're going to do the natural log of 0.1 divided by 3 equals -2t. And you're going to get time is equal to 1.7 minutes. So now we want to compare these results. We can see that these numbers were really bad estimates. What we got when we used this linear interpolation. So why is that? Well, this is an exponential function, so let's kind of draw it out. So moles per liter here. So we are interpolating between, so time equals 0 and C equals 3 up here. And when time is 1 down here, and when time is 1.4. And we are extrapolating outside of that range. So this is an exponential function. It kind of looks something probably like this. And it levels off from what we could tell. So when C equals 0.1, it levels off a little bit past 1 minute. So probably like around like 1.15 or something like that. Or no, sorry. I need to look at the true value. So it actually levels off to a very low concentration when time is equal to about 1.7. This is the estimated value. Wrong. So it levels off around 1.7, and what we were doing was we were literally just creating a line between these two values. So you can see where the error comes from trying to use this line to estimate an X or a Y value along this line. They're really close to each other, and it's not going to be, numbers of magnitude off, but there is going to be some error when you are using this interpolation in order to estimate values, specifically when you're doing this for an exponential function. And you see that the error gets really big, in this region over here. It's a little smaller over here when you're like just past the point where, when you're closer to the points that you use to create the relationship, it's gonna be a little bit more accurate. But over here, you can't even trust what you're getting from this equation that you created.